Our next speaker is Magdalena Kowalczyk. Magdalena is a research engineer with Autodesk Research Industry Futures and is based in London, UK. For most of her career, she has worked with customers to develop innovative solutions using cutting-edge design and manufacturing technologies. Her specialties include part performance optimization through generative design, additive manufacturing technologies, and design for manufacturing and assembly with over a decade of experience working across different industries such as aerospace, automotive, industrial tooling, medical, and more. Currently, Magda's research focuses on the industrialization of construction, where she's been conducting research on the state of the industry, exploring technologies and trends, and identifying opportunities for innovation and growth within the sector. Her work seeks to apply a wealth of manufacturing expertise to the convergence of the manufacturing strategy and construction demands. In her free time, Magda enjoys watching documentaries and reading books, especially on naval history. Please welcome Magdalena Kowalczyk.
Thank you, Ali. Good morning. I'm Magda, I work as a research engineer, and I'm here to tell you or introduce you to Autodesk research and what we do around industrialization of construction. So Autodesk is changing how the world is designed and made. At Autodesk Research, we advance this mission by exploring new possibilities where others might see roadblocks. We are a diverse team of scientists, engineers, industry experts, and we conduct industrial research to help our customers design and make a better world. So how do we approach innovation at Autodesk? Product teams are focusing on the needs of what our customers need now. And they work on 1 to 3 years timescale. At research, we're setting our sights farther into the future. We're looking 5 to 10 years into technology which might be still far from widespread adoption. And we're using this process called backcasting when we're trying to speculate the multiple features and then figure out the steps we need to take to actually meet the most desirable one. So this research, we have multiple groups. Science groups are developing this technology, the new technology, and engage with industry, with technical and academic communities through papers, patents, and prototypes. Industry Future team, so that's the one I'm part of, takes the technology from the labs and into the real world. And we're working with customers on applied projects, and these projects are never easy. There's always some workaround to be done, but the end goal is to produce a proper workflow for our customers. And then technology centers, they support external industry research, and we are in one of those downstairs. And our partners conducting their own experiments with their own set of problems are supported by Autodesk spaces. Not just spaces, but also technology and software, and our experts as well. And what's important is they provide us insights into those emerging technologies and trends and signals. And this research engineering team, which develops that technology, they allow us to demonstrate easily the new techniques and the new innovations, so we can actually showcase this to customers and even our product teams. And the strategic foresight team, which they actually look more than 10 years. They look 10 years plus, trying to get this, foresee what the future might bring. The technology centers are the home to world-class fabrication capabilities and are an engine for connection and collaboration. They intended to bring a global innovation network to accelerate also our research goals, like the convergence of design and manufacturing. To accelerate your research, anyone can apply to become a resident of our outside network. On-site residents get batch access to one of the free technology centers where you get workspace to like office space, access to machine, technology, software, and experts, but also training and support of our great technology centers staff. We also have global residency programs. So this is the virtual network where you gain access to virtual community, virtual talks, events, but the opportunity of networking with other residents and Autodesk staff. So Autodesk is committed to supporting industrialization of construction and, of course, supporting our customers in this transition. And this is regardless if we are in product, customer success and consulting, or research. We offer a suite of products and platforms to support the many needs of IC applications, IC industries, from the design to manufacturing to production. Our customer success and consulting orgs are there to enable customers to get the most out of our products. So they're there to help you find the best way of using our products. And in research, we're exploring the frontier of new technologies and practices. In blue is Industrialization of Construction Focus Group from research. Now let's take a look at some of our projects. Many of you, I think, are familiar with the project. The need for over 1,000 distributed healthcare clinics sparked a collaboration between Virginia Tech and Howick to redesign a clinics, especially for control of disease spread. So Howick's automated framing system was used to demonstrate that the primary structure can be produced and erected within one day as opposed to several months using traditional methods. The initial design was constructed in Entebbe, Uganda, using local materials, and similar system was utilized in constructing multiple mini hospitals in Zambia. And here you can actually see the design, the steel framing, and the external area. It's a bit like this. Isolated wings around external outdoor area, which will have a triage and waiting area, so it will limit the cross-infection between patients. The next project I would like to showcase is the robotic digital twin. Our researchers developed a tool set, which allows you to create virtual environment for the robot and a virtual copy of the robot. And then you take the VR controller and you can manipulate the end effector of the robot. Very complex movement of the robot arm will just simply be calculated based on the movement of the VR controller. So this process allows for very intuitive programming of robotic movements, which then prevents potential clashes with environment, but also with another robots if this is a factory setting, for example, when you've got multiple machines. The operator can control the robot by being next to it, but also can control in a remote location, so it can be another town, another country, apparently even another planet. Okay, and the last project to showcase is the DA Smart Bridge. And we work, DA is a civil engineering company, and we work together on this project exploring how the robot can build its own infrastructure without any human input. So the vision was to use decades of experience in building bridges and the data accumulated to supplement our own knowledge in manufacturing, of design and manufacturing, to feed generative design algorithm. And this, once built, the bridge would interact with its users and the environment to understand how it's being used, and then this knowledge would be then fed back to a software to inform the next generation of bridge design. And through this project, we worked with our Fusion 360 colleagues to advance the capabilities of our software. The bridge was designed using generative design to reduce weight, but also, most importantly, to make sure that it's actually manufacturable. So using all the manufacturing constraints. In this case, we had 3D printing, but there are other manufacturing constraints like for milling or die casting. So you can choose another method if you wish. And the second one, we helped develop robot simulation natively within Fusion 360. And this allowed us to check the motion of our 7-axis robot over the million points which make the toolpath. And the bridge was printed here in Boston, downstairs, which if you join us for the tour, you will see some artifacts from that build. Just to give you some statistic, it was 24 kilometers, which is 15 miles of toolpath, and the weight was roughly 960 kilograms. So these were the projects, and it's actually only a fraction of what is actually happening within research. So now I would like to draw your attention to a recent deep dive into the construction industry. And I'm sure most of you have heard this. By 2050, the predictions are there will be 10 billion people on our planet. So the AECO industry must create spaces for this growing population, from residential building to critical infrastructure, we just haven't got a choice. We set out on a mission to explore how industrialization impacts the adoption and development of technology in construction. So what have we found? Firstly, there is a huge demand for civil infrastructure, and this drives adoption of innovative technologies. However, the industry is struggling to keep up due to social, economical, political, educational, and environmental challenges. Secondly, segregation makes it even harder to adopt IC technologies. We notice if the trade is sort of individualized, it's easier to adopt IC technologies. When more trades get on board, it gets harder and harder. Thirdly, variation in supply chain. It's not only availability of parts and materials, but the inconsistency between them. You can have the same material from different suppliers, and it's not going to be actually the same. Disconnected production workflows. So this is still a big challenge. And automation. So it has the potential to improve quantity, quality. However, the adoption, innovation is still, it varies, and it can vary across countries, regions. And finally, the rural presents a great opportunity to apply IoC technology and make a real difference for people working there and living there. So now to finish off, let me briefly tell you what my team and I are up to. So our vision is to ensure a digital continuity in workflows from design to make in IC applications. So you can see we are tackling the disconnected workflows from the previous slide. And the idea is to have those three engines which talk to each other, exchange data, and at the end, we getting design which we know is not only going to be manufacturable, but we also know when and where it's going to be produced. Okay, so now to truly finish off, that is our call to action. Please engage further with our work. You can follow us on social media. You can go to our website. You can check our blog, check our latest publications. If you're interested in applying for outside network, application is there. You can find more information. But the most importantly, we are here in large numbers. Just come and talk to us. And let's design and make better worlds together. Thank you.
Wonderful job. Thank you so much, Magdalena. Quick question for you, Magdalena. The work that you all are doing is spanning industries. It's pulling together convergence moments where we're looking at these interlocks between multiple industries and how technology is being used. But I think some of the most fulfilling work that I've seen so far is also being done in partnership with customers. How would you agree with that?
That is the most important for us, and especially for Industry Future, which I've been part.
Yep.
Well, it used to be called differently. Now it's Industry Future. We've been always working with customers, and that was the most important bit and the most enjoyable one. Because that's when you really can get that understanding. Because like reading websites and stuff, like it's okay, and it's all what we do, but it's the customer who will give you the true drive to do your work.